Road to Olympiad.
Welcome to RTO. Consider the following problem. Find the greatest perfect square, which is not a multiple of hundreds, such that after deleting its last two digits, the remaining part is still a perfect square. We may recognize plenty of perfect square, but how many of them have the above property? And what is the greatest perfect square among them to have such property? Pause the video if you like to give this problem a try, and when you are ready, keep watching to learn how to solve it. To solve this problem, we start by letting x squared to be the perfect square we are looking for, and y squared to be the perfect square obtained after we remove the last two digits from x squared. Without loss of generality, we can further assume that x and y are both positive. Also, we can let n to be the two digits that are removed. Since n has two digits, we have n is between 0 and 100. Note that n cannot be 0 because x squared is not a multiple of 100. By the condition given in the problem, we can obtain these equations. X squared is equal to 100y squared plus n. Rearranging, we have x squared minus 100y squared is equal to n, where we can factorize the left hand side to be x minus 10y times x plus 10y. Here, we can further let u to be equal to x minus 10y and v to be equal to x plus 10y. Then we have uv is equal to n, x is equal to u plus v out of 2, and y is equal to v minus u out of 20. Now, notice that in order to obtain the maximum value of x squared, we need y squared to be maximum, which need y to be maximum. To do so, we need v minus u to be maximum. Recall that uv is equal to n, so we have uv is between 0 and 100. And notice that u and v are both positive, and v need to be greater than u so that y is positive. We have 0 is less than u, is less than v, is less than 100. This gives us v minus u is less than 100. Dividing by 20, we have y is equal to v minus u out of 20 is less than 5. This implies that the maximum value of y we can have is 4, which gives us v minus u is equal to 80. Rearranging the equations, we have v is equal to u plus 80. Substituting back into the first inequality, we have u times u plus 80 is less than 100. This can only happen when u is equal to 1. Otherwise, the product is going to be more than 100. With this, we can find that v is equal to 1 plus 80, which is equal to 81. And thus, we have that x is equal to 1 plus 81 out of 2, which is equal to 41. This implies that the perfect square that we are looking for is 41 square, which is equal to 1681. And this marks the end of our solutions. Post in the comment below if you have any thought on the video, and if you haven't subscribed yet, consider subscribing. This will really help us out. Anyway, see you in the next video. Thank you.